Hello, and welcome to another day and another challenge of the advent of cyber from Try Hack Me. I am running behind because I received my booster shot on Monday and I have been under the weather and I am playing catch up. So, in this video, I am going to be solving day 9 challenge, and we are leaving web exploitation and moving into networking. So, now where is all this data going? McSkitty recently found out that a large amount of traffic is entering one system on the network. Use your traffic analysis skills to determine what kind of activities Grinch enterprises are performing. So, for this challenge, we're going to use a packet analysis tool named Wireshark. It's installed on the attack box. I am using Kali virtual machine. Kali Linux is also installed here as well. And a packet analysis is a technique to capture and intercept network traffic that passes through a computer's network interface. And packet analysis may also be called with different terms, such as packet sniffer, packet analyzer, protocol analyzer, or network analyzer. So what happens is it captures network packets in real time and displays them in a human readable format, which is good for us, right? It provides many advanced features, including the live capture and offline analysis. So we're going to actually review these packets and answer questions about them. So on such unencrypted protocols such as HTTP, DNS, and FTP. So, as it says, the required skills and knowledge is assuming a basic background to complete the challenge, basic networking concepts, TCP/IP, OSI model, TCP handshake. So to use this, you need to have administrator privileges to complete this. As I said, Wireshark comes pre-installed on the Try Hack Me attack box. I'm using Kali, Kali virtual machine. It also is installed on that as well. Let me download the task file because I'm going to need that. I'm going to save it. And it's going to save in my download directory. And this is if you use the attack box, it shows how you can access it from there. Or if you don't have it, how you can download Wireshark. And a little bit about Wireshark. It has command menus, that's the pink here. Display filters, that's the green. Listing of capture packets, that's the blue. Details of selected packets, that's the gray. Packet content in hexadecimal and ASCII, that's the orange. So filters. Berkeley packet filter syntax is used in packet analyzers to filter specific packets pre-capture. Filtering packets is beneficial when locating information within a packet capture process, because when we open this, and as you will see, there's a lot of packets, right? So once you open Wireshark, it will be very beneficial to start learning and start filtering on specific protocols, because it will be cumbersome to try to scroll to find what you're looking for. It will almost be like looking for a needle in a haystack. Wireshark syntax is the primary method we will use in this room to locate certain protocols and information. So below we have included some examples of using Wireshark display filters. And so it's saying, let's assume that we are looking for all packets that have been sent or received by the following IP address: 172.21.2.112. Thus, the following filter is helping us to display all network packets that have the IP address 172.21.2.116. And so it says IP address, IP dot address, so that's the IP address we're looking for, double equals, and then the IP address we're looking for. As a result, we can see that we were able to show only the packets that we need. Next, we can specify certain protocols such as HTTP, showing all packets for that specific protocol. We can also specify a domain name to narrow down the search. The following example shows that we are looking for HTTP packets that have the google.com domain name. HTTP contains google.com. Next, we can also look at a specific port. Let's try to filter and list all packets for remote desktop protocol. We can do that by using tcp.port, tcp.port equal 3389. That's the port for remote desktop protocol. However, assume that you are monitoring the network traffic and you want to exclude the RDP packets. In this case, we can use the not Wireshark rule as shown below. And it's kind of small, but not is in front of it. Next, we will perform the packet analysis technique using Wireshark on various protocols, including HTTP, FTP, and DNS. So we need to make sure we have the Advent of Cyber 3 packet capture file is imported. So let me open that. So I'm going to say Wireshark. And it's opening. And now I'm going to say file open. And I'm going to go to downloads. And I'm going to say Advent of Cyber. So now going back, it says we will be performing a packet analysis on the pre-captured network packets and the PCAP to analyze. We will be performing a packet analysis on the pre-captured network packets and the PCAP to analyze HTTP traffic. Once we open the PCAP using Wireshark, it will show a lot of network traffic since we connect using our RDP protocol, making our work harder. However, we will be using a Wireshark filter to focus on web requests only. In this case, we are dealing with the HTTP protocol. Therefore, we can use Wireshark rules to make it easier. We can apply the following rule to the Wireshark filter to show only the HTTP traffic HTTP. So let's do that. So let's say HTTP. So as you see, removing that, it's showing everything, right? So here is, as it say, apply a display filter. So I'm going to type HTTP. And now we're only showing HTTP requests. The following figure shows all HTTP traffic that has been sent to and from the web server. In the first packet, we can see that the web request is sent from our machine 192.168.195 to the web server, which is also our machine. In the information section, we can see also that we sent a GET request trying to get admin content. On the next packet, the web server replied to the sender with an HTTP request code 404, which meant it is not found. Suppose we need more details on a particular packet. In that case, we can expand using the greater than sign, the hypertext transfer protocol subtree for more details about the sender request, such as the IP address of the host, web user agent, and other info. We can specify the HTTP method. In this case, we can specify to show all the GET requests using the following filter: HTTP request method equal GET. Keep following the GET HTTP request and answer the question in this task. And then in the second scenario, we check HTTP. So let's try to answer the questions and then we'll go back. Okay. So it says in the HTTP number one GET request section, what directory is found on the web server? What directory is found? We're going to type login. What is the username and password used in the login page in the HTTP number 2 post section? So now let's do HTTP dot request. Oh, I can't auto dot method equal post. And if I go here to the bottom, I'm going to go HTML form. So username is McSkitty and password is Christmas 2021. McSkitty Christmas 2021 exclamation point. What is the user agent's name that has been sent in the HTTP number 2 post section? User agent, try hack me. Is there a way I can copy? Oh, let's see. So they didn't show this, I don't think, in the lab. So what I'm going to say is right click, follow HTTP stream. And this is kind of like a shortcut. And I'm going to copy this. Because what I'm trying to do is I'm trying to copy the flag. And I can't copy it in the first form. So here, I can't copy. You see, I can't copy that. So, but you see the filter has changed, right? Now you see TCP.stream equals 7. So now I need to change it back. You see the, it goes, our latest filters at the top. So I'm going to change it back. And now I can go right click, follow HTTP stream, and then I can copy this again. And paste. Okay. I needed the full. Try hack me. Let me see. Hold on. Yeah, let me try the full. the message of that DNS query. So let's go back to the DNS section. Okay, going back to the DNS section. Okay, DNS is like a giant phone book that takes a URL like HTTPS, tryhackme.com, and turns it into an IP address. This means that people don't have to remember IP addresses for their favorite websites. Excuse me. The provided PCAP or packet capture file has DNS packets that have been received by our sender. The domain name that we will look into is packet.tryhackme.com. Please note that is the domain name used in the packet capture file as an example. First, make sure that you open the packet capture file, then use the Wireshark filter. We will specify DNS packets. This can be done using the UDP.port filter. By default, the DNS protocol is running on UDP port 53 and sometimes on TCP port 53. In this task, we will go with the UDP port. So let's try changing. Let's close this. Let's go here and let's say UDP port equal 53. Okay. So now we're looking at all of the DNS, and now we're looking for the text. Let's see if there's a faster way. Okay, so by double clicking on the first DNS packet, we see the following. By expanding the domain name system subtree, it is obvious that this packet is a question. Okay, so okay, so what are we looking for? In the DNS section, there's a text DNS query. What is the flag in the message? Okay, so let's see. Now we said we can look for by domain, right? This is the long ways, but let's see. Okay. Okay, here's the TXT. Okay, let's follow UDP stream. So what I did, I said, so let me go back. So UDP 53, right? Okay, so then I found the TXT. So follow UDP stream, and here is the flag. In the FTP section, what is the FTP login password? So if we go here and we say TCP port, and I think FTP is 23. 20, 22, 21, 21. FTP is 21. Yes, is on port 21. Yep. So, but we could go up. 22 is SSH. 23 is Telnet, I believe. So right, so the provided packet capture file has FTP packets, file transfer protocol, that have been received by our server. For this task, we will be looking at FTP traffic and Wireshark. Like other protocols, we will be using Wireshark filters to look into FTP packets. By default, the FTP server is listening on TCP port 21. Therefore, we filter and list all FTP packets by using the following filter: TCP.port equal 21. The following figure shows all FTP packets, and we can see all packet details by checking the field section. Okay, so now what is the question? In the FTP section, what is the FTP password? So let's go back here. Let's go here. Here's the password. Try. Can we? So I'm going to say right click, follow TCP stream. This is the password. Try hack me. In the FTP section, what is the FTP command used to upload the secret.txt file? Store. And we can see that here because we typed in our user, try hack FTP, the password, and we changed working directory to files. Then we entered passive mode, and then this store, so secret.txt, to upload the secret.txt file. In the FTP section, what is the content of the secret.txt file? So let's go back and let's go TCP port equal 21. Okay. Okay, it says request store transfer complete. Okay, so the filter is FTP data. So I had the wrong filter. FTP data. So if we say right click, follow TCP stream, this is the flag. And that's it. So we have changed sections and we have started looking at networking and packet analysis and looking at network traffic. So these was actually someone was on an actual computer and was interacting with the server, FTP servers, DNS servers, and the like to generate this traffic. And so we inspected it and we were able to answer these questions. So, again, I'm playing catch up due to not feeling well. So I can't wait to see you in the next video where I am solving a challenge, whether that's an old challenge or a new challenge in the advent of cyber um, space. So I can't wait to see you in the next video. Have a good day. Bye.